So, um, my discussion today with you would be about clean pragmatic architecture. Just a bit of context first. I assume many of you have heard before of clean architecture. This word, however, may be new in this context. But let's start with the beginning. First, let me introduce myself. My name is Victor Rentea. I'm a Java champion, writing Java for over 15 years. And what I do for a living today, I do trainings in many companies throughout the world, starting doing that 8 years ago. My topics are Spring Hibernate, Java 8, functional programming, architecture, including Clean architecture in much more detail, clean code unit testing, performance reactive programming, and secure coding. So this is what I do today, day to day, basically. And in my spare time, I do conferences and meetups like we do here today. Right. So typically, I go in companies to teach, but I also have groups that you can join or videos that you can get on Teachable. But super interesting. I have a YouTube channel that you should check out. I have a lot of recordings of past events there, plus a community that has over 3,000 members. We speak English, and I will welcome you to join. I'm trying to do some event every month on different topics, stuff that I learned, stuff that is catchy or interesting today. If you want to know more about me, here is my website. So I won't lose more time with this. Let's jump to the part. So the first chapter, the first point. Oh, and I would like to invite you all to ask me anything at any moment. I will try to keep an eye on the chat as we speak. So the first chapter, data structure, something that is super important to create a clean, maintainable architecture. Now, just a second. All right. Let's start with a very simple problem. I would like to have a chicken. I would like to have a chicken, and you ask for the chicken to another service, and this is what they give you. This is their representation of a chicken. This is what they understand to be a chicken. This is a DTO. However, what you want to work with in your core logic is probably much more appealing. It's another representation of the same chicken, but in a much more nice form for your goals, right? This is what you want to use in your core logic, not the chicken that they might send you over wire. But there is this big difference between the stuff that comes, the data structures that come from outside, and the stuff that you want to work with inside your complexity. So DTOs are evil, in short. Super true today in the world of microservices. This is probably at the root of most of problems that we have today in design. Let's see. So as a round trip, as an overview, I won't go into super much details, but as the main point, data structures that come from outside of your system you should be very wary with them, because they are very often bloated with fields that you don't really need. In contrast, in your core logic, you would love to work with data structures that have exactly the number of fields that you would need, not nothing extra. So I would hate to see a method taking an object with 17 fields, out of which I use only 3. I want to have super specialized structures that are nothing more than really needed in my core logic. Also, DTOs tend to be flat because that allows them to be more backwards compatible and to be more, let's say, inert in time, to not break their past contracts. So DTOs are usually flat, whereas in our core logic, we want a deep, rich domain model that will match our understanding of the domain as close as possible, right? So you don't want a flat 10 fields, 20 fields object. You want little objects composed together. Of course, DTOs carry the perspective about the chicken that those others, that other system had. Whereas you want data structures tailored to your problem to help you implement your stuff as easy as possible. DTOs have a fixed design. You can't really change them. And usually, today, what I see most of the time, you either generate those from some open API using a Maven plugin, or you might use some client jar that you are given. So you don't usually have the freedom to change and to add methods to those DTOs, whereas we would love to do so if we we want to have the ability to employ OOP to simplify our logic. We want to be able to put logic next to the state, something which is impossible if you can't change the code of those objects, right? DTOs are typically mutable, right? Getters and setters. And if you want to make them immutable, you will get a lot of pain from the frameworks that usually non-marshal those objects. Now, in our core logic, we would like to favor immutable objects on the other hand, because they are safer to use and all sorts of benefits that I won't enumerate here. DTOs typically don't carry any constraints. You can have like many fields which are null, or you can have some aberrant data combination in there. They don't validate their own state, whereas the structures that you work in your core logic, you would like to trust that they are consistent. So we would love to prefer models that guard their invariants, that keep track, that keep themselves safe, right? So, and also very, very important, sometimes DTOs do change in time, and change in time because the provider decided to upgrade to version 2. Now, it will be a drama, it will be a horror movie for your entire logic right, to collapse because the data structures on which it operated changed, right? That's a horror story. So you don't want, you want to control the structures that you operate on. So that's the point here. Don't implement complex logic on foreign data structures, right? Now, two problems here are, what is complex enough to deserve dedicated data structures? And what do we consider foreign? Now, we usually consider foreign structures that come from external services, from other applications, right? But there is this weird case of nano services. I see this more and more often in the companies that I go to. The habit of having many super tiny microservices, and you know that you are in this game if you ever hear this line that you have this shared team of 5 developers maintaining 20 microservices. That means that those microservices are super small usually, right? Now, there's a funny thing happening in this scenario. You see, the same team of 5 developers maintains these 3 nano services, and because it's the same homogeneous team, that team will share the same understanding about the world, will share the same ubiquitous language, they will have the same mindset about the problem, right? About the concept. And you will end to funny scenarios. Like, imagine some developer here wanting to implement a story, a feature which spans all 3 microservices, nano services. What he will have to do, if he follows what I said, he will have to map to and from different DTOs every time he exits the system, every system, which will be a lot of pain. It will cause a lot of damage, a lot of pain. So, in such a case of a super tiny microservice, then it might be acceptable to share the DTOs inside the same bounded context, inside the same team, right? Something which is usually a bad idea, but here it could work. But I have to confess, I'm not a very big fan of this idea of nano services, because I believe they add too much accidental technical complexity to the story. But anyway, in case System 1, however, wants to call a microservice from another team developed by someone else, then that's where the danger is. Because the data structures that come from there, they could have a different mindset, a different representation, out of control, etc., etc. This is where you want to decouple DTOs from internal structures, all right? Just in case you are in this game. So what I'm talking about decoupling data transfer objects that move as JSONs or whatever from your core internal data model, right? Now, there is a niche, a very corner case which maybe doesn't deserve to create a domain model for. Imagine this software ecosystem composed of different microservices and then a huge external system. I don't know, a SAP, a Salesforce, something big outside. And to integrate with that stuff, there is this boundary system here that basically allows everyone to talk to that system only through them. Right? If that's the case, if you are building such an adapter, you may not need to create a domain model of your own, because you are you are a huge, full-fledged adapter pattern, technically. An entire system working as a boundary system. But there is this corner case in which domain models may not pay off, really. Now, The coupling between DTOs and domain models, they come with a price, of course. You have first to create more classes, of course, but we found ways to limit the effort by generating those from YAML or from whatever, right? So we were smart. But with mapping, mapping, get set. We're not very proud of this kind of code, right? So again, we try to be smart in this, and we are using auto-generated mappers such as Mapstruct. Now, don't get me wrong, I don't have anything against Mapstruct, but there is this trick. Mapstruct, these automatic mappers are basically trying to reduce the need to write boilerplate by automatically copying the content of fields if they match the name. So as long as the fields have the identical names, the mapping happens automatically without any custom code. And this itself, it's comfortable, it's cool. Broken again for me? Wait a second, I'm looking. I hope it's not from my side. Let me check. No. Good. Now, this idea, the point that the fields are copy-pasted automatically if they match the name, that thing can be tempting for developers to keep the models in sync, to keep them mirrored to each other. And that's a very dangerous thing to do, because you created DTOs in the first place for them to diverge versus the entities. They shouldn't be kept in sync by all means. You remember the discussion between DTOs and internal data structures. You want to have freedom, to have smaller objects, deeper models, less fields, all sorts of DTOs and entities should not be kept in sync, right? Just 1 second, I have some here. No stream for me. I think I have a technical issue with the streaming stuff, but I will continue. This is all recorded, so yeah. Now this, so in short, with data structures, don't start implementing complex logic on foreign data structures, right? Okay. Now, second chapter, logic. Now, let's first go to the museum. This is a rare painting which captures the vision about how code looks in the view of a developer. This is the code. This is how the code looks if you don't do anything to impose some structure, on it. Now, the first thing we do, most teams have layers, of course. So we impose layers to organize this in, let's say, groups of classes that talk to each other in a certain direction. And we have controllers, services, and repositories. Most teams I see today that implement Java backend, they have this, right? Controllers, services, and repositories, which is perfectly well. However, there are some large systems or monolithic systems that have so much domain to cover that the service level grows wildly, goes enormously. So what they do, because layering is not enough for them, they need to split code vertically in subdomains or bounded context in the same application, right? I wouldn't talk about this kind of clustering today. It's interesting, it's out of scope for this talk, but it's very, very powerful if you apply it carefully. Now, if the service layer grows too big, you might want to introduce an additional layer of abstraction that I will call Facade. You might know it as application service from domain-driven design, but you will see a slight difference between these two along the way. Now, this Facade will call into the domain service because that's when you can say you have a layered architecture. The definition of a layered architecture is that these groups of classes, they call each other in the same direction. The calls never go backwards. So in other words, the repositories should never call back into the domain services, right? So if you ever find yourself doing that, what you can do is to pull that data, that logic from the repository up into the domain service and move the orchestration up in the call hierarchy. That's a very interesting refactoring to do. But the idea would be that layers are followed, meaning that the calls only go downwards, right? Now, there is an interesting, we call the layered architecture to be relaxed if we accept the calls to bypass sometimes the layers. In other words, a Facade can go directly to the repository in practice, right? Good. Now, this Facade thing that we introduced is basically an application of separation by layers of abstraction, a very subtle principle. A very subtle principle that tells that every time there is complicated stuff, you should break it down into sub parts, and so that at the top level you only see the big picture, right? So the muscle is composed by fascicles, fascicles by fibers by myofibrils. You don't see all these if you don't care. You only see the muscle. If you want to dive in, you can see the detail, the components, right? Separation by layers of abstraction with the goal to simplify the top level view of your flow. So when you open the facade, the workflow of your use case should be obvious, should be brain dead simple, right? And you will push down the details in lower level classes. This is what I will talk about here. Okay. Now, a bit of let's say heads up here. Heads up. Warning moment. Writing code is not a construction like some, let's say, managers that don't understand our ways tend to believe. Code is not a construction. We don't lay out floor after floor after floor. No. Code is much more organic. Code is like a garden that needs continuous care. You can't just put more stuff in and everything to be fine. No, code will grow without, maybe too much. You need to trim this bush. You need to plant a flower. You need to remove this part of the tree. The code needs continuous care. So, continuous refactoring. Okay, so here is logic. We have a logic. We have to implement a lot of features, a lot of procedure, a lot of logic. And there's business throwing requirements at us. And the default place to put this logic was traditionally the service. This is what I see today in every project I go to. Services, yeah, hail the chicken. So services. But then, maybe after several years of career, you read this book. This book. My life was never the same after I read it, and I can testify for many other dozens of developers whose lives were changed by this book, by the perspective that it puts on the design of enterprise applications. However, I wouldn't advise you start reading this book from scratch. I would advise to start with this other book, the red book, the Implementing Domain-Driven Design by Vogue Vernon, much more accessible and implementative-oriented book, and then the blue book. Now, these books technically tell that you should put more logic close to where the data is. Basically, in the end, it is an aggregate. And you will start pushing logic in there. You will start realizing that if this chunk of logic is business logic and I want to share it across my system, the best place to put it is inside my domain model, right? And that will simplify enormously the complex flows. It has a very subtle, interesting effect that it simplifies the code exactly where it's very, 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 very cloudy, very dark. Right? Exactly there it puts the light. Now, we introduce a facade. Now, how do we play this game? What do we put in facade? What do we put in services? And that's a question difficult to ask, even for domain-driven practitioners, entrenched practitioners. It's still tricky how to answer this question. So here is my approach. Basically, there are, practically speaking, what I see in different companies. I have this huge opportunity, this amazing chance to see code. Every week I see code from 2 or 3 companies. And I get to debate on their design. I get to see what people are doing right now. And I've seen 2 ways to implement these application services or facades. One way is to implement one class per each and every use case. So if you have an endpoint like get order by ID, you have to have a service named, or a facade, to be honest, named exactly as the endpoint. But that you can judge for yourself. That would lead to many stupid, brainless classes like 5 lines of useful code. This leads to over-engineering in the sense there are too many files. Okay, and the bad news is that it doesn't really shield us from the real problems. The real problems are not classes which are very short. No, that will just make the packages very big. But the real problem is the God classes, the classes that grow enormously and you have a very hard time to break them down. And this approach doesn't shield you from falling in that trap. Why? Because imagine place order service. Imagine how many, 4,000 lines of code, perhaps more. in a single use case. Now, if you just follow this rule blindly, you might fall into the same problem with God classes. You might have these huge classes. So it has two problems, this approach. Now, what do? I don't do this. No. What I do instead, I start implementing many use cases in a single facade, like place order, get order by ID. Now, this, of course, runs an even bigger risk to degenerate into a huge God class. So, how do you fight that? By continuously extracting logic out of the facade into the domain services. Oh la la! So, how do I do that? Again, I will start to implement every use case in a method in the facade. Quick note here. This technique I've used in 7 projects, and other teams have started using it, and I've seen other people that were going towards the same ideas in that other companies. So I'm not putting this just to look what I dreamt last night. No, this is the production. Right? So facade, implement the use cases. If the use case is super trivial, like get order by ID, it ends in a single method. 5 lines of code, method, end. If the use case is complicated and the business logic starts and complexity in general starts to accumulate in the facade, I will immediately push it into a domain service in order to keep the facades decent, right? 200, 250 lines, decent, right? Push the complexity as soon as it grows into the domain services, either because it's complex or because they want to reuse it in different places. So either single responsibility principle or don't repeat yourself, SRP dry. For either of these principles, break classes further and further down the chain. Now, something very interesting happens the moment I move some logic from the facade into the domain service. The magic is that then I cross a boundary. I cross the boundary between the facade and the application module and the domain module. I cross the domain boundary. And that's super important because, you see, we said previously, DTOs are bad. DTOs are not yours. DTOs are the API model that needs to be kept safe, but you shouldn't use the DTOs inside your core logic. So the moment I move from this module into the domain is a one-way road. I can't go back at all. So when the moment I moved into the domain with some flow, I know for sure that I will keep in the domain. And something magic will happen. This module here will depend on the module here. Imagine 2 Maven modules. Imagine module A, module B. If module A calls into B and depends on B, once I got into the B module, I can never see anything from here, ever. These are out. So at the moment I step into the domain module, I take down my shoes, like in the Buddhist temple, I enter peacefully, I'm there in the domain. I will never look back into DTOs, okay? So basically, whatever complexity I get, if that gets promoted to the domain, to a domain service, that will guarantee that that logic will only use primitives or domain objects of my own application, internal data structures of my application. And this is super important because I want to keep the most complex part of my logic written solely on data structures that I control. All right? This is the point. Another disclaimer here. If you have very little domain logic of your own, in the microservice world, it can happen that a microservice doesn't really do much. At some point, you might give up creating a domain service, a domain model altogether sometimes. So there are, not so often, but you could. There are some applications that don't need a domain at all. I mentioned one example, the adapter one, the one that operates, it integrates the ecosystem with some external big app. All right. One more word about the domain services. So you saw me extracting it here, but there is a trap you might fall in. You see, whether or not you're using facades, whether or not, just if you have an order service, and if the order has 30 fields, then order service runs a big risk of degenerating into a 3,000 lines of code class in several years, because you dared to name a service with the name of a large entity. This is risky. And from my experience, I can tell you I would avoid this. So what I will do, I will put a more specialized name, placeholder service. You can't really put that much stuff in such a class, can you? So if you have services named like some of your largest entities, that's a dangerous thing to do. Try to break them down because they will continuously tend to grow. Okay, that will lead you to more cohesive domain services, technically speaking. Good. So what does a facade do as an overview in my architecture here that I'm showing? It converts the DTOs from outside into entities internal to my code, right? Either in line with the automappers, however you please. Since it's the first class that carries logic, that sees the data from outside, it is its responsibility to validate the inputs, okay? Annotations or ifs, however you please, that's the place to validate, at the beginning of the flow, of course. Most applications would benefit from starting and basically wrapping transactions around every use case, starting from the facade. That will basically wrap everything that you do in a single ACID transaction. I'm talking about relational system, relational databases here, right? So think Hibernate. Now this works perfectly unless you are building some high frequency system that has to avoid connection starvation issues. I actually have demos of this in my trainings of performance and stuff. There are many ways you can go in that, and if you have to handle thousands of requests per second, including reactive flows. And most importantly, the role of a facade is to orchestrate any use case which is complex enough. So any use case which is heavy will be split into parts that will be pushed into domain services, and the facade will remain the orchestrator. So if you look at one of the methods in my facade, what you will see is just maybe 5 or 6 calls to different domain services and repositories, and not much logic. Basically, almost no ifs, definitely no loops, just calling and that's it, orchestrate. Okay, that is what the facade is doing. Perfect. So we kind of wrapped the idea. So to say so, we have this domain in the middle, and you have this facade at the beginning in another module that calls into the domain. This is what we covered until here. Let's see next. One day, a domain service in your core wants to call an external API. What will happen? The very fact of calling the external API will pollute the domain service. Why? Because data structures from outside, remember the chicken? Data structures from outside, weird integration protocols, particularities of the API will start creeping in my domain and mixing with my core logic. And that's bad. So what we do in this case, like a mandatory pattern, every time you call an external service, you call it not directly, but through an adapter. That's like a mandatory pattern for me. You are not allowed to call directly, but only through an adapter. And then what happens? Well, that adapter will take on the responsibilities to map and to know more about the details of the API that you want to consume. Now, if we try to put the adapters in a separate module from the domain, that will force your domain module to depend on the infrastructure, because that's how it works in Java, right? If you want to call a class from this module, you have first to import it, right? You have to import it from the domain in order to see the classes, right? And that's bad, because that moment the chicken can get in. The data structures from outside might slip in your domain. So what do? We extract an interface from the adapter. Pay attention. I took the API of the adapter, made it here in the domain an interface that is implemented from the adapter. But as I did that, the dependency just got inverted. Let me replay this for you once more. So we were here, look at the dependency, and then because the interface moved in the domain, the dependency just got inverted, right? So in other words, in more words, how does this work in reality? You are in your domain, and at some point, you want to call some service from outside. The first thing you do, you express your desire about what should come from that system into an interface that you put in your domain that speaks your entities, your objects, your model. And then You put on the yellow gloves, the yellow gloves that you go and you want to wash the toilet. You put on the yellow gloves and you go and you implement the adapter. By getting your hands dirty, by working with DTOs and basically converting this user into a user DTO that you want to get and send to the external world. So this is how it feels. In code, the domain never sees the adapter, although at runtime it will be able to invoke it, because Spring is smart enough to know how to inject here the only implementation it knows for this interface. So it's pretty straightforward if you think of it a second, right? Okay, now this idea of having codependencies going one way and the calls the other way is called dependency inversion principle. My friend, if you don't know this, at least the name, I'm sorry, but you don't stand much chances at an interview. This is actually part of the solid principles. You should know this. This is a D in the solid principles. The fancy name is that abstraction should not depend on details. Details should depend on abstractions. Now, what does that really give you? Anything from the lower level can never, nothing from the lower level can ever enter your domain. Okay, it's impossible. Right? Now, you can use this technique every time you want to integrate with some other system with all the integration paradigms available to you, right? Synchronous, asynchronous, files or DB links. Anywhere, any time you have to work with a structure that is not yours, you can use dependency inversion to keep that structure or that API out of your domain. Good. And you see, this trick of separating into modules basically relies on the compiler to enforce this boundary, right? The compiler will fail if you in the domain, you will try to reference from here a class in here because you didn't know about that class. You can't see, the compiler can't see that class. That's definitely a technique to use for medium large applications and for mid-junior teams. But if your team is quite experienced and the application is rather small, or there is another alternative to it, which is to rely on tools that could assert dependencies between packages. What do I mean here? You just read about this. No classes that reside in package domain should depend on classes that reside in package infrastructure in any of the sub-packages of my application. What is this? Is it a test on Jenkins? Oh my God. This is the framework called ArcUnit, right? That will look at the bytecode and fail the pipeline if you crossed the boundaries in the wrong direction, if you have a domain depending on anything from infra. So basically, that will not require two modules anymore, but one single module plus unit tests. But you have to have in your culture the idea of automated testing. You have to have these tests working at every moment. So, just an alternative to dependency inversion principle. The idea is the same, but just I'm not using modules. I'm using tools. That's it. You will still need the interface. You will still need the same stuff, but you don't need two Maven modules, technically speaking. Okay, so all of that for trying to build a domain which knows nothing about the outside world. That's good for you because that would allow you to focus on your complexity and not on integration concerns with the outside systems. All right, so let's see how they all fit together. Just one second. So 50, 26, 35, I have, oh, okay, good. The domain in here will sometimes have to call outside some external API, right? Then you would do that by means of an adapter. You put the interface in the domain, like we just said, and we'll implement it into in an infrastructure module using dependency inversion to decouple that dependency out from your domain. Then in front, there are DTOs coming from your client, from your API, right? Now, these DTOs here will never enter the domain, but they will be handled by Facade, converted, and then if the complexity accumulates, it will get into a domain service speaking the words of your entities, right? Now, this is the application layer. If you read a bit of this stuff before, if you were aware about the clean architecture, application, domain, and infrastructure. Good. Now, if you look carefully, the dependencies always go inwards. The domain doesn't depend on anything external. It's just self-contained, agnostic. right? But then, I mean, the benefit is that nothing from outside can ever enter the domain. The domain knows nothing about them. Cool. We get that. But now let's tackle another hot topic for many teams. Pay attention. Database. Oh my God. When we talk to the database, we could, in theory, use the same technique we use for talking to external services by putting an interface in the domain, implementing it outside, using dependency inversion to hide details of database. But I find people do this, teams do this, only if they choose to create a separate persistence model from the one that they work with in their domain. What do I mean? Please imagine here a Java object with just fields, methods, nothing more. And here are the entities. I'm talking just about Hibernate. This discussion mostly happens if you are using Hibernate to persist stuff. Now, some teams choose to create a separate model. So they have a customer domain model here, a customer domain object, and a customer entity here. If they choose to do that, they might want to keep that model, the customer entity, out of their domain. However, that comes with a huge cost, huge pain. Those teams are really frustrated. I will tell you, I saw them. Because all they do every day, they map from this to this, and from this to this, or this. They are doing just mapping. 1/3 of their code is just mapping code. So it's a high price to pay. Still, what you see right here in front of you is the famous onion architecture. The core idea being that all dependencies go inwards. Domain is completely isolated from anything outside. Good. Now, out of pragmatism, I will destroy this model. I will tell you, put entity in here, and then someone will raise and say, wait a second, but that will mean that I need to concern about persistence when I design my entity model. No, it doesn't mean that. It means that you have to learn Hibernate much better than you learned it until now. If you have a NoSQL, people persisting in Mongo, Cassandra, I don't see them struggling that much. They usually persist their entities as they are in the persistence. Only teams with Hibernate think of, oh, let's separate. Because Hibernate is a bit invasive in your programming model. But there are ways to keep that influence out of your domain. You can still design a well-crafted domain-rich model even if you are persisting it with Hibernate. It just calls for more knowledge about the framework, honestly. I know this because I'm teaching this. So if you know Hibernate good, I actually have recorded a talk about this at my community. How can we design expressive entity models using Hibernate that would make any domain-driven practitioner proud without creating a separate model? So go ahead on my YouTube channel, search, it's there recorded for several months ago. Now, being even more pragmatic, I will merge everything from the beginning, from the front, with everything from the back. Besides removing that entity from here and putting them basically here, besides that, I will merge everything in just one module. One module from everything that is ugly and dirty, and one module for what is sacred. Now, if you read articles about clean architecture, I must warn you, those articles are trying to be extremely general purpose. And I've seen teams struggling to apply by the book the words of those famous IT thinkers. The problem is that they almost always get to over-engineering. Ourselves, we created such applications, several of them, and we never thought it made sense to break these from these, for example. It never made sense. We once met and we discussed, does this make sense? No, it didn't. And we were developing for 4 years, the application, and it still didn't make sense to crack it here. So it is good enough to have just 2 modules, ugly and sacred, right? All right, and then what? Well, I call this the pragmatic onion architecture, by the way. Now, this trick also opens the door for some interesting design opportunity. Imagine a search query, bringing in the interface stuff like this. Customer, last order date, region, these things are basically an aggregation of data from different entities in my domain. This is just for presentation purposes. right? This is just for presentation purposes. It doesn't have any meaning in the domain. And I see some teams trying to get such an object through the domain. So they are taking it from the database, right? Basically creating a value object in here and then mapping the value object to a data transfer object. But I'm a very pragmatic man, very pragmatic guy. Why? This shouldn't exist. You should select the DTO directly from queries, right? In Hibernate, select new. Or if you're using JDBC template, feed directly the DTO and throw that DTO out, bypassing the domain. If something is not complex in logic, it should not pass through the domain. All right? Ooh la la. A lot of strong statements over here. Now, a recap. What is an onion architecture? By the way, throughout history, it had different names. You might have heard of it as hexagonal, ports and adapters, or clean architecture in the words, of course, of Uncle Bob. These architectures, they all share this idea that the domain should remain agnostic. Agnostic of what? Agnostic of user interface. That used to be a very big problem in applications when they had a think please, swing or desktop client. The business logic tended to spread in the thick client also. So they have a hard time pulling that logic from the front end back into the back end services, right? Now, this happened, I don't know, then 1995, 2005, it's still happening, but the project starting doing this, starting violating these rules started in that period. More recently, people put logic in the database, in procedures, or in large SQL queries full of business logic. And that basically spread the logic from Java also into database, coupling them, locking them to use a specific vendor for database and giving them a hard time to migrate from PLSQL, for example, to Java, and causing inconsistencies because the code in procedures was different than the one in Java, for example. I've seen many such examples. Now, more recently, today, how to say this? The main point in which we don't follow clean architecture is that we tend to allow the structures from other services to penetrate our domain. This is a mistake. Your domain should be agnostic of any external service, right? And this is where the domain-driven book comes useful, and to really understand what bounded context means, what ubiquitous language represents, and to understand that you need to break down the semantics of your concepts into separate universes, separate systems, right? And super important also, fundamental, the domain should always be super easy to test without needing to raise a Docker and treat wiremocks to test it. It should be tested easily, right? Probably with some Mockito stuff, but it should be tested easily. And those tests on the domain should run 100 per second as a speed, or just in memory, no spring started. Why? Because I told you, most of our complexity we will push into the domain, push. And then if the complexity is there, all the cyclomatic complexity gathers there, all the branches to test, this is where I want test coverage 90%. This is the place, if possible, 100 if possible, in the domain. Because that's where the requirements of my application are. That's where most changes would occur. That's when I have headaches to understand what's there, the domain. So the domain should be easy to test. Good. One more thing. In those articles that I mentioned that are on the web, including this, there is this phrase that your domain should be independent of intrusive frameworks, but it's very, very vague. What does that mean? Is Spring intrusive? Is Hibernate intrusive? Spring, definitely it's not. But Hibernate, it can be. As I mentioned, there is this video that you could watch. I will share the slides afterwards, maybe tweet it tonight. I can't do it right now, tonight. Tweet the slides. You can watch this video of how I use Hibernate in a way that doesn't couple my model with persistence. You need to know more Hibernate a bit, but your domain will still be supple and elegant. All right. So, basically, this is it. We have the application. You have the domain. We have this stuff in front, the facade, it receives the DTOs, converts, sometimes responds directly because if it's easy. If it's complicated, goes into the domain. The stuff in here uses repositories working on my own entities, right? And then maybe if I want to go out through the dependency inversion, go out, come back, done, right? This is basically what we discussed. One more slide, and then we're done. Anemic domain model. Now, like a teaser to learn DDD, teaser. If you have entities that just have getters and setters, right? And it is said that domain-driven design leads to better maintainable code. Why? Just look at this. If you have an anemic domain model, like some getters and setters, just structures, right? Versus a rich domain model. Now, what does that mean? An anemic domain model will only have getters and setters, so that all the logic will accumulate in services, huge services. What does the other alternative say? It says, okay, getters perhaps, but try to push as much logic you can into the entities themselves. Why this is good? This is easier to find when you want to reuse logic. It's right inside the domain model. You know what's the most fascinating thing? The complexity of our use cases, it's not homogeneous. Use case 1, use case 2, use case 3. It's not like this. No. The complexity in the real project looks like this. Low, 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 bang. A complicated use case. Low, 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 bang, bang. This is how the complexity is dissipated among use cases. And you know what's fascinating about DDD is that it chops from this complexity exactly from the parts which are more complicated. That's where it optimizes the code. That's where it makes it more readable, by extracting parts of logic into the entities themselves. Things that get much more interesting with aggregators, consistency, boundaries, really, really fascinating stuff, with the end goal of imposing decoupling between the parts and providing like cells, like independent chunks. I know I'm running out of time. Like a teaser. So even if you don't hope to start a DDD project tomorrow, my strong advice is to you to read that book, the red book, Vogue Vernon, and then the blue book. It will open your mind, really. But I went further than that with my talk. It's not just that. I wanted to be pragmatic, first of all, and then the first thing is, okay, pragmatism, and to be, let's say, not to commit some big mistake. Now, key points. What did we talk about? We said DTOs are evil most of the time. There are some excuses of boundary systems, but most of the time, if your application manages state, if you have some transitions, if you have some invariants to enforce, then you need a domain, right? You want to build yourself a deep, rich domain model, that supports implementing logic in the best way possible. You want to protect your domain by decoupling the adapters with dependency inversion or arcunit, like I showed you. Don't let persistence concerns influence the way you think about your domain model. That would be a mistake. If in order to do that, you need to learn Hibernate, so be it. But don't get in the mindset of having tables and then Java classes. No. You have Java concepts, right? Rich, deep structures that have to be persistent. That's the attitude. Continuously refactor to keep the code supple. Don't over-engineer. Don't say one class per use case. That will lead to both tiny classes and won't protect you from huge ones either. And very important, the entire team should understand the design goals. You shouldn't be the only one having ideas. You should work together, do design katas, explore the ideas with the team, and so that they all understand. Right? And always think critically. Never follow blindly the words of someone else, even if that someone else is someone deeply respected in the community, something extremely, extremely heavy. Think for yourself. They all are trying, even perhaps me. I'm trying to be generic. Think, apply these to your concept. What does it make sense? What does it doesn't? What does it not? No? I thank you all for your attention, and I will be happy to answer any questions you might have, but I'm out of time. So what can I say? An honor to be here. How do I signal I finished? I raise my hand. What do I do? And questions.
Yeah, Victor, I joined you as well, so we see you finish your talk. Thank you very much for a talk.